Greetings, dear students, and welcome to 2019 examination-based contact session. This is Mathematics 3, Bes Mat21. My name is David Yambo, and I will lead you through some of the problems that typically students experience when it comes to their examinations or assignments. The presentation is meant to help you with preparations for your upcoming examinations, and we, as I said, will take a brief look at some of the topics that students experience problems with, either in the exams or in the assignments, given our experience. Now, this is not an exhaustive presentation. It should not be taken as a substitute for your study guide. You should still work through your study guide. You should study using other materials that are either cited in your study guide or any textbook that claims to contain topics that we are covering should be useful in this module. One of the topics that we'll look at is on read, analyze, and interpret data. This is in your unit number 1. Now, the learning outcomes of those units should guide you as to what we expect you to know for us to say that you've mastered this module. The things that we expect you to be able to do after having gone through this unit. And we will take a look at 2 of these, and the others make sure that you sort them out. As I said, we will only concentrate on those that we've observed students experiencing problems with the most. The first one of these is on extracting pie charts, information from pie charts with up to 4 sectors. This is one of the exit learning outcomes, and we should be able to, given a pie chart, we should be able to interpret the data on such a pie chart. Now, a pie chart, sometimes also called a pie graph or a circle graph, it makes use of sectors in a circle. This is a circle. And if this is a circle, then this is a sector of a circle. Now, a circle, if you go full circle, we take full revolution, then the angles inside there is 360. And therefore, if you split this circle into different sectors, then the sum of the angles of these sectors must be 360 degrees. So this would probably be something like 45, and then the other one, and then the other. So if we add these angles of the sectors, then the total must be 360. So that is the first thing that we need to know about circles. Now, as such, the angles of a sector in a circle is directly proportional to the frequency of the data, which means the more the data, the larger the angle of the sector, or the larger the sector which represents that particular frequency. Now, as I said, the angles of all the sectors in a circle must sum up to 360, and therefore 360 corresponds to 100% of your data. Now, to determine the angle of a sector in a pie chart, the formula is very simple. Okay, that your angle of a sector is given by frequency of a data divided by the total frequency multiplied by 360. So that is the formula. Now one can play around with this formula. If you are, for example, asked to find instead, you are given the angle of a sector and you're asked to find the frequency of the data, then it's just a matter of making the frequency of the data the subject of the formula in this formula, the subject of this formula here. So you can rearrange things as required, and therefore that will give you the frequency of the data given the angle of a sector. Okay, as I said, the angle of a sector corresponds to the angles in each of those sectors, and that is directly proportional to the frequency of the data. So one should be able to work this with these two formula. The first one either finding the angle of a sector, or the second one either finding the frequency of the data given the other two pieces of information. So please master this. Make sure you do as many exercises as it's possible using this formula, so that when it comes to the exam, you know exactly what you need to do. I must also perhaps mention at this point that it's also possible that you might be given a histogram instead of a pie chart. Histogram is simpler than a pie chart because the frequency is already given there. You just need to work out either the percentage and so on. And working out the percentage, we'll look at it later today. Now, the second learning outcomes we'll look at is calculate and interpret the mean of a small set of discrete data. Okay. If you're given a set of discrete data, you should be able to work out the mean, you should be able to work out the median, the mode of the data. And if you look at the definitions that are given in your study guide, we have that the mean is really just defined as the sum of data points divided by the number of data points. Okay, so if you have the data, say 34, 45, 32, and 60, those are the data that you're given, and you're asked to find the mean of these, then what you do is you take the sum of the data points, which means you have 34 plus 45 plus 32 plus 60, and then you divide this with the number of data points, and the number of data points in our case is just 4 because we have 4 sets of 4 data points, so we divide this by 4, and then you get your answer. That will give you the mean. And the second one is the median. The median is the middle number in an ordered list of data. Okay, so what that means is that the first thing that we do is we order the list of data points that we have from the smallest to the largest. So in our case, we have 32, 34, 45, and then 60. Now, if the number of data points is odd, okay, which means, for example, suppose in this case we add another one, say 30, okay, then that would be simple because then the 30 will be here, and we consider the middle number, which in our case is 34. But if the number is even, so let's suppose that we get rid of the 30, which means in this case we have 4, then you look at the middle 2 and then you take the mean of those, which means in our case we'll have 34 plus 45 divided by 2, and that will give us the median. So for an odd number of data points, it's easy. You'll have exactly one middle point. But for an even number of data points, you will have 2 middle points, and then you take the mean of those 2. You take the sum and you divide those by 2. That should give you the median of your set of data points. And then the last one is the mode. And the mode is just the number that appears more frequently in your set of data points. In our case, obviously, we don't have one that appears frequently, but if we take an example of 34, 45, 32, and then maybe 45 and 60. Then when we look at this set of data points, we realize that all the other points are appearing once except 45, which means 45 is appearing twice and it's appearing more than the others, and therefore the mode in this case is 45. So if you follow these definitions, then you should be okay. Mean, you take the sum of the data points and then you divide by the number of the data points. That gives you the mean. The median, you consider the middle number in an ordered list of data, which means you first order your data from the smallest to the largest, and then you pick out the middle one. For an odd number, that's straightforward. For an even number, you will have 2, and therefore you take the mean of those 2. You add them and you divide them by 2. While for the mode, you only consider the one that appears more frequently, the one that appears the most compared to the others. So that, I think, is okay. And then the other type of problems that typically we experience problems with is called the 3-step word problems. These are problems where we need a maximum of 3 steps to solve. Okay, and if you look at page 55, there's an example number 2, and we will illustrate this working through that example. And the example says that you have a shopkeeper who bought 8 packets of sugar for 60 Namibian dollars. And now you have 2 questions. The first one is, how much did he pay per packet, he or she? And the second one is, how many packets of sugar can he buy for 75? We need to work through these 2 problems. Let's start with the first one. If 8 packets of sugar cost 60, then to get the cost of 1 packet, we just need to divide 60 by 8. Because for 8, you have 60, and therefore if you want for 1, then you divide 60 by 8 to get the cost of 1 packet. And as such, what we get is 7.5. That's $7.50 per packet. That is straightforward. And then for the second one, to work out the number of packets of sugar that he can buy with $75, we need to divide $75 by the cost of 1 packet, so that we get the number of packets that he can buy with 75. So the cost of 1 packet, we already worked it out in the first step in Roman 1, and therefore what we get is we get 75 divided by $7.50, and that gives us 10 packets of sugar, which means that the shopkeeper will be able to buy 10 packets with 75 Namibian dollars. It's really that straightforward. Now let's look at another example. Suppose your father bought a car for 50,000 Namibian dollars, and then he sells the car for 20% less than what he bought it for. What is his selling price? What did he sell the car, or how much did he sell the car for? Now, first thing that we note is that 20% less means that the new percent is 80, it's no longer 100. The 100% is 50,000. And therefore, if they are saying less, then it means that he did not recover the full 50,000, but he got 20% less of the 50,000. So 20% from 100 will give you 80%, isn't it? And therefore, the selling price will be 80% of the 50,000, and that will give you 40,000 if you work it out correctly. So you have 80 over 100, that's your 80%, multiplied by 50,000, and you get 40,000. And this means that your father's selling price of the car is 40,000, and that 10,000 difference is he made a loss. That's the 20% loss that your father incurred when he sold the car for 40,000. So the selling price is 40,000. Now, it's very important that you try to understand these problems before you start answering these three-step problems. Make sure you know exactly what is given and what is required. So read through as many times as it takes for you to understand that problem. And it also helps to just note down a spare piece of paper the pieces of information that are given and what you are required to calculate. That will help you in guiding you exactly what you need. How can you use what is given to obtain what is required? And you should be okay. Now, the other thing that we will look at is on common fractions. Most people experience problems with fractions because their arithmetic and their working are not really as simple as working with just whole numbers. Okay, if you have whole numbers, if you are adding whole numbers, that's straightforward, and so on. But in most cases, fractions might create a bit of a problem for most of us. We have three different types of fractions. Okay, the first one is called the proper fractions, and in proper fractions, we have the numerator is less than the denominator. So the top is less than the bottom. That's called a proper fraction. Here I've just given an example of 2 over 3. 1 over 2, for example, that's a proper fraction, or 7 over 9, that's also a proper fraction, for as long as the numerator, the top, is less than the denominator, which is the bottom. And then we have the improper one. The improper one is just the opposite of the proper fractions, which means the numerator is now greater than the denominator. The top is greater than the bottom. In this case, the example that I've given is 5 over 3. But you can also take 10 over 3, 10 over 7, 15 over 9. All those are improper fractions. And then the last one is called mixed numbers. These are numbers which contain whole numbers as well as fractions. In this case, we have given an example of 2 and a third. So which means 2 and 1 over 3. That is a mixed number. Now, mixed numbers and improper fractions are sort of related, because one can rewrite an improper fraction into a mixed number and back, which means you can also rewrite a mixed number as an improper fraction. For instance, if you look at the 2 and a third that we have, that can be written as an improper fraction. What you do is, like in this case, you multiply the whole number by the denominator, which means here you have 2 times 3, and then you add 1 divided by 3. Okay, so that gives you the 2 multiplied by 3 is 6 plus 1, that gives you 7 divided by 3. So these two numbers are equal. They are only written in different forms. The first one being the mixed number, and the second one being the improper fractions. Let's just do that again on a clean piece of paper. That if you have 2 and 1/3, and you want to rewrite this into an improper fraction, then you multiply your whole number, which is in front, by the denominator. So we have times, and then you add the numerator of your fraction. So that gives us 2 multiplied by 3, and then we add 1, and then we raise that on top over your numerator, and that gives us 7/3. And going back is also that simple, that you just divide 7. 7 divided by 3 is what? Is 3. Sorry, not 3, but it's 2. 7 divided by 3 is 2. And then the remainder is 1, because 3 multiplied by 2 is 6. And you're left with 1, and that 1 is what you put as your numerator of your fraction. So you have 2 and 1/3. It's that simple. One should be able to go from one side to the other. Now, adding fractions, I think, should be pretty straightforward. And I think your study guide is also clear on this. And therefore, we're not going to spend time on arithmetic or arithmetic of fractions, addition, subtraction, multiplication, and division. If you have problems with this, then you can always get help from your study guide or from someone. You can also call me. You've seen that my number is on the cover page of this presentation. But I think for the most part, we've noticed that many of us do not experience problems with arithmetic or fractions. Now, just in case you want to look it up, 66 to 75 pages, 66 to 75, should be able to help you with arithmetic of fractions. What we will look at today is on expressing one quantity as a fraction of the other quantity. Okay, this is the problematic part in most cases when it comes to fraction. I want us to look at the following example. You have a school with a total of 12 teachers. You have 8 females and you have 4 males. And the question now is, what fraction of teachers is females and what fraction of teachers is males? Okay, it's really straightforward. As I said in previously, all you need to do is make sure that you understand the problem and know what is given and what is required of you to calculate. So to find these fractions, we just need to write down a fraction with the number of female teachers in A, the number of female teachers as the numerator, and the total number of teachers as the denominator. While for B, we have the total number of males as the numerator and the total number at school in whole as your denominator, and then you simplify. What does it mean when we say you simplify? What we mean is that your fraction must be written in its simplest form. Your numerator and your denominator should not have a common factor. That's what we mean by by simplifying. And therefore, what you do is you divide both the numerator and the denominator by the highest power, not by the highest power, but by the highest common factor of the two. If there's any. If they don't have any common factor, then it's fine. Your fraction is already simple enough. But if they have any common factor, you need to divide the numerator and the denominator by the highest common factor, and then your fraction should be simple enough. So in A, what we have is if you have 8 female teachers and you have a total of 12 teachers, then the fraction of female teachers is 8 divided by 12. But then you realize that 8 and 12 have common factors, isn't it? 2, for example, is a common factor, but 2 is not the highest common factor. The highest common factor is 4. And therefore, you divide 8 and 12 by 4, and you will end up with 2 over 3 as the fraction of female teachers at the school. That is the fraction of female teachers in its simplest form. And in a similar way, you work out the fraction of male teachers, and what you have is for male teachers, we are told that there are 4 male teachers at the school, and therefore you have 4 divided by 12. And now again, you consider the highest common factor of these two numbers, of the 4 and 12. And again, 2 is a common factor, but 2 is not the highest common factor. The highest common factor would be 4. So you divide 4 and 12 by the highest common factor, which is 4, and you obtain 1 over 3. And that is the fraction of male teachers at the school. Now, the important thing here is that to just verify that your answer is correct, the number of school teachers is a whole, okay? And therefore, if you add the fractions of the female to the fraction of the male teachers, your answer must be 1. Okay? And it's the same that when you add the number of female teachers to the number of male teachers, you should get the total, which is 12. And therefore, if you add the fractions, the total must give you 1. And therefore, in this case, if we add 2 over 3 plus 1 over 3, 2 over 3 plus 1 over 3, then of course your common denominator here is just 3, and you have 2 plus 1, which gives you 3 over 3, and that gives you 1. So if you realize that when you are adding these fractions, you're not getting 1, then 1 or more of your fractions might not be correct. So in this case, what we get is 2 over 3 plus 1 over 3 gives us 1. So that's how you express one quantity as a fraction of the other. We have in a second example, you have a water tank, and you're told that when it holds 750 liters of water, it's 3/4 full. Okay? And therefore, what we want to find out is how much water does it hold when it is full completely. What does this mean? This means that if we let, say, X be the amount of water that the tank holds when it's completely full, then what we have is 3/4 of X. 3/4 of the full amount is 750, which means 750 is 3/4 of the tank. So that gives us 3 over 4 multiplied by X is equal to 750. And then remember, we want to find the amount of water that the tank holds when it's completely full, which we said is our X, isn't it? And therefore, we just solve for X by dividing throughout this equation by 3 over 4. And what we get is X is equal to 750 divided by 3 over 4. And if you work that one out, you should get 1,000 liters, which means the capacity of this tank is 1,000 liters, so that 3/4 of 1,000 is 750. So I think that should be straightforward. So there's absolutely nothing wrong with introducing unknown variables that will help you in solving your problem. Like in this case, we had to call our unknown, which we are required to work out, the amount of water when the tank is full. We called it X, and now we need to calculate X. So you introduce an unknown variable, come up with your equation that you need to solve. In our case, the equation is 3/4x equals to 750, and then we just need to solve this equation for x, and we obtain our answer as 1,000 liters. So these are the types of problems that we need to be able to solve, and I'm advising all of us that we do as many exercises on these problems as it possible, so that we master the techniques of solving these problems. Otherwise, these are the things that I felt we needed to highlight in this presentation, but that does not mean that these are the only things that you need to know. As I said, you need to study your study guide in full. All the units in your study guide are important. If there are problems, as I said, my number is on the cover page of this presentation, and therefore don't be selective. Don't try to second guess an examiner. Work through the whole study guide so that you master all the possible problems that you can possibly find in your exam. We hope that you're not gonna encounter problems with these problems in the coming exams anymore, and do as many exercises from textbooks in the library as possible. The exercises that you have in your study guides are not enough. Read widely. There are so many textbooks that you can find related problems. Solve those and make sure you master them. As I said, practice makes perfect. You know what they say, we don't study mathematics, we do mathematics. So it's very important that you do exercises. And I wish you all the luck with your examinations. Thank you.